Practice problem. The following table represents ordered pairs from a linear function. Use the table to answer the following questions. A. Calculate the rate of change or slope. I know that my slope is going to be the change in the y's over the change in the x's. So I will look at these values and see what the changes are. When I go from this x to this x, it's 5 minus 0. There's a difference of 5. And this y to this y will be 25 minus 35. So it will be a negative 10. And then in terms of the rate of change, that would be the change in the y's. So negative 10 over 5, which is going to give me a negative 2 for the slope between the first two ordered pairs. Now I want to see if this is linear, so I'm checking the next pair, and that'll be 0 minus 10, which is negative 10, and then 35 minus 15, which is a positive 20. So again, change in y's, 20 over negative 10, so I get a negative 2 for the slope. I have the same slope between each of the pairs of points, so I'm pretty certain that this is indeed linear. And my rate of change, or my slope, is negative 2. Determine the equation for the line. Well, to find an equation for a line, I need to know the slope, and I know that it's a negative 2, and I need to know the y-intercept. So I'm thinking about, where do I have an ordered pair? If I do 0 comma something, and I do, I have 0, 35. That means my b is 35, and I can use that form y equals mx plus b, but I'm going to write it in terms of the variables that I have here. So my equation for my line will be f of x instead of the y equals negative 2x plus 35. Okay, so that equation is in function notation. It has the f of x at the start, and the variable inside the function part is an x, which matches what I have on my table here. Create a scenario to represent this linear function. While I'm thinking about it, I know a couple of things. I know I'm starting at 35 in the y direction. So whatever the y direction is, it has to start with 35 of whatever it is. And then it's decreasing because I have a negative slope, so it's going down as whatever happens across the x-axis grows. So if I do something with time, I could have 35 at the start, and then it decreases by 2 every day, and eventually it'll get down to 0. I could do something like that. So I'm thinking, oh, maybe just an agriculture example. So my barn has 35 bales of hay. So we're starting with 35. So each day we use 2 bales of hay to feed the livestock. So that fits my equation pretty well, because we're starting with 35 and going down by 2 for every day that we're using the hay. Based on your scenario, complete the following questions. The input or independent variable is always going to be your x, or whatever is in that first position on your table, and in our table it is an x. And then our y value, or our dependent variable, is the f of x. So the f of x. The units for the input or independent variable for the x, in my scenario, that's going to be each day. So that's going to be days. So x is going to increase each day. One more day happens. Okay. And my output, what's happening, that's the number of bales of hay. So that's this column here. I start with 35 and then go down to 25 and then 15 and eventually 0. So allowed values for days, well, 0 is going to be the smallest, and we can use it because we have 35 bales on the first day, or today, and then The rest is the number of days after. And so I'm thinking that I don't know how many days, but then when I think harder, I do know that for my equation, if I have f of x equals negative 2x plus 35, I want to know what happens when my output or my dependent variable is 0. So if I change that to 0, so I'd like to solve for x because that'll tell me how many days until I have 0 bales of hay. So first thing I'll do is subtract the 35 from both sides. And I have negative 35 equals negative 2x. And then divide both sides by negative 2. And I end up with x equals 17.5. And that means my x value is 17.5, and my f of x value, remember, I put 0 in. So that's an ordered pair that I have for my graph, but that also tells me that the biggest value I can have for my x is 17.5. So I'll put that in here. And at that point, after that point, I won't have any hay left. And I can't go negative because I can't have negative bales of hay. The range, that's finding what are my output values, what's the total, the highest output value I could have, down to the lowest. And remember, you always write your interval notation lowest to highest. But in this case, I do have a line that's going down because we're starting at 35 bales and going all the way down to 0. So even though I think of them backwards, I'm going to write them smallest to greatest for interval notation because we always do that. Interval notation is always smallest to greatest. Then the scale, that's what I'm going to need for my graph. And I'll think about that in a second. The label, this is going to be the days since, or days, maybe after is a better word, today. And then the bales is going to be just the number of bales. When I look at my graph, I need to figure out for, I'll do the y-axis first. I see it has to go from 0 here to 35 at the highest. And I'm wondering, can I use a scale of 1? But I think there's only 24 blocks on here, so I'll have to go by 2s. And then I'm just going to label every other tick mark. So it'd be 2 for the first one, 4 for the second one, 6, 8, and then 12. And I needed to go to 35, so I'll stop at 36. That's plenty. And then I need to write in number bales of hay. And for my x-axis, the input is the number of days, and it's the days after today, and it goes from 0 to 17.5. So when I get down to my graph, I can just use one block for each day because there's 24 blocks and 17.5 is smaller. So I'll be able to mark those in. I'm just going to mark every other again. I need a title for my graph. And since I have the number of bales of hay here and the days after today here, I can use dependent and independent to write my title. And so I would do bales of hay by day. So bales of hay by day. Independent by dependent. So that's how I can write out a title every time. Now I'd like to graph my information about my hay, and I see I have ordered pairs here, and then I have one more ordered pair right here. And I'm going to use all 4 of those to make my graph. So starting 0, 35, So 0 for the X direction and up to 35, there's 36, so I'm right below that. My next ordered pair is 525, 5, and then up to 24. So 525 is right about there. I see before I even move 17.50, so there's 16, 17.5 and 0, there's a point. And my last ordered pair is 10, 15. So 10, 15 will be right there. Now I need to try to draw a straight line. And I know that's not perfectly straight, but I'm going to tell you, if you're writing on paper, I do expect you to use like a piece of paper folded and the straight edge for that, or a credit card, or your cell phone or your calculator, anything with a straight edge that you can just use to make your lines nice and straight. I have an excuse that I'm using this little input device and it's hard to get the hand-eye thing going on it. So this is as pretty good as I can get with the device I'm using, but I do expect you to make really nice straight lines on your paper. So there's my graph, and you can see I did not draw anything in quadrant 2, 3, or 4 because for the scenario that I came up with, negative numbers were not allowed. I couldn't have less than 0 bales of hay, and I couldn't have a negative number of days before today. It didn't make sense for what I was writing. Identify the X intercept. So when it says identify, we're asking you to write down the ordered pair, and the X intercept is where we cross the x-axis. So that's this X intercept here that we'd already found. That's 17.5, 0. And describe it in terms of the application. Remember, this is the number of days, and this is the number of bales of hay. So it's days, bales. When we're trying to interpret our intercepts, the number of days is 17.5 and 0 bales. So in 17.5 days, we will be out of hay. That's an interpretation for the x-intercept. The y-intercept is where we cross the y-axis, and remember that was at 0.35. And again, if I use this key to help me, it's days, bales, so 0 days, 35 bales. So today I have 35 bales of hay. So that's a good description of the y-intercept.